This is what could happen if we don't slow down the pace of global warming. Already there are signs. Animal species are on the move, some wreaking havoc on ecosystems. Rising sea levels threaten tens of millions of human lives. But there's a scientific revolution underway to combat climate change. Technology is moving fast. But can it outpace a warming world? The Earth's climate has always changed, but rarely this fast. In just 250 years, the planet has warmed by almost 1 degree Celsius. Celsius is a scale that scientists use to measure temperature. At the current pace of warming, most climate scientists agree we'll be about 2 degrees hotter in 50 years and at least 3 degrees hotter by the end of the century. What will our world look like at each of these stages? And what scientific and technological advances are currently in progress to address each of these thresholds? We know what's causing the problem. Greenhouse gases like methane and carbon dioxide, which act like a blanket around our planet, trapping in heat. And greenhouse gases are increasing faster than ever. Evidence for this comes from projects like this one, just 1,000 kilometres from the South Pole. Antarctic ice built up in layers over millions of years. British climate experts read the past by drilling out and examining ice samples, or cores. This ice core is 750,000 years long.
If we go back 750,000 years, we can see 8 climate cycles. So that's 8 times we've gone in and out of an ice age. So if we look at those 8 climate cycles, we can see what the temperature was doing. But critically also, we can get at the carbon dioxide, the methane, these 2 greenhouse gases. We can see what levels they were in the ice. And what we find is they're actually remarkably consistent with temperature. They track temperature extremely well.
Robert Mulvaney is a paleoclimatologist, one of the world's leading experts in the field. He's examining a shorter or younger ice core. Trapped inside 18th century air from before the Industrial Revolution.
What I'm going to just do is just take my gloves off and warm it up, because once I've warmed it up, you ought to be able to see the air bubbles in the ice. So about 10% of the volume of the ice core is air. I can hear it crackling away as the little tiny air bubbles that are under pressure because they're from deep in the ice sheet are all bursting as the ice melts around them.
No matter where carbon dioxide is released, it disperses evenly in the upper atmosphere. So air over the Antarctic has the same CO2 concentrations as the air anywhere else in the world.
So this is pre-industrial air, and what we're hoping to see is what the level of carbon dioxide is in the air before man started using vast amounts of fossil fuels and pouring carbon dioxide into the atmosphere. Wait for the instrument to stabilise. So I've got 288 parts per million.
Today's levels of carbon dioxide are 386 parts per million. So there's been an increase of 100 parts per million in less than 250 years.
It might not sound a big leap, 100 parts per million, but we're 100 parts per million higher than we've ever been over the last 750,000 years, and it's going up 2 parts per million every year, relentlessly. Unless we can slow down the amount of carbon dioxide we pour into the atmosphere, that level will continue to rise, and it will have consequences on the climate.
Concern over climate change led the United Nations to set up the IPCC, the Intergovernmental Panel on Climate Change. a group representing the findings of over 4,000 climate scientists. At its head, Dr. Rajendra Pachauri.
The science related to climate change has reached a level of sophistication and reliability which leaves absolutely no scope for doubt that human beings are impacting on the climate of this earth.
Already, at nearly 1 degree warmer, we're seeing small but significant impacts on the natural world. As not only air but ocean temperatures rise, many marine species are shifting their ranges, moving out from the equator towards the poles. Tierney Tees, a marine biologist working with the Monterey Bay Aquarium, is studying this phenomenon. Tierney's research is focused on one of the strangest fishes in the sea. The mola mola, or sunfish, is the heaviest bony fish in the ocean, growing up to 12 feet long.
It looks as if it didn't get quite finished. Some people think that it's had its tail bitten off. Why would you design a big open ocean fish with no tail?
Molas used to be a rarity in the cold waters of places like northern California, southern England and even Alaska. But now they're being seen more frequently. To find out how far their range is shifting, Tierney has been tagging mola mola to record their movements.
And stop.
You have to sneak up on them because some molas are very skittish and others will just let you sidle up to them.
There we go.
The secret is to push the tag in to an area of the molar where we know it won't pull out. And that's right below the dorsal fin.
Nice. Good stick.
Once attached, the tag stays on for 9 months.
It essentially records the entire animal's travel diary. And then at a pre-programmed time, it releases from the animal, the tag floats to the surface and uploads all its data to satellite. That satellite relays it down to our computers. And from there we can analyze all that data.
1, 2, 3, I'll push down.
Tierney's research is in its early stages, but a clear picture of the mola's new range is starting to emerge. And what's clear is that even with a small rise in temperature, the mola is on the move.
Climate change is much more than, oh, it's a little hot in the ocean. Because adding that amount of heat, 1 degree, you're changing all manner of things. You can change the oxygen levels, you can change the nutrient levels, you can change circulation patterns. Climate change is changing a whole bunch of things simultaneously.
Because of global warming, average temperature lines are moving out from the equator at the rate of about 64 kilometres per decade.
If that rate continues or increases, it will cause many species to go extinct because they can't keep up with that rate of change. And in turn, because species depend upon each other, you have the danger of ecosystem collapse.
And ecosystem collapse is exactly what's happening in the pine forests of British Columbia. Trees are being devoured by a beetle that was once kept in check by winter temperatures. A less than 1 degree rise in temperature has allowed the mountain pine beetle to flourish, decimating the forest. Bill Wilson heads up pine beetle research for the Canadian Forest Service.
It's emotionally overwhelming. When you see red pine trees, it's not a sign of the fall and the winter season. It's a sign of death. Those trees have been killed by the mountain pine beetle.
This beetle is responsible for the largest insect infestation in North American history. In the past 10 years, the pine beetle has destroyed about 13.5 million hectares of forest. That's an area the size of Greece.
What I'm looking at here is a lodgepole pine that's been mass attacked by mountain pine beetle. What they do is the females that successfully attack the tree excrete a pheromone, and the pheromone attracts large numbers of other beetles. Very quickly, the trees are overwhelmed. Once the beetle successfully gets under the bark, what it does is it will start to feed on the tree, and then it'll lay eggs. Those eggs hatch typically within 7 to 10 days, and the larvae start feeding immediately.
They weaken the tree and disease sets in. The outbreak can't be controlled with insecticides, so at the current rate of destruction, 3/4 of the mature pine in British Columbia will be gone by 2019.
It does give one pause to think that an insect the size of a grain of rice can cause the kind of damage that this is causing in North American forests.
The attack of the pine beetle is just one of many ways that a rise of almost 1 degree is affecting the delicate balance of nature and threatening the survival of species. The pika, native to the USA for over 40,000 years, could be the first mammal to become extinct as it struggles to adjust to climate change. In Africa, the annual migration of over 1 million wildebeest is under threat, as drought destroys the grasslands on which they feed. In Central and Southern American tropical forests, 70 species of harlequin frogs have already become extinct, as climate change is allowing a lethal fungus to flourish in their midst. Across the world, coral reefs, home to 25% of all marine life, are dying as the oceans heat up, absorbing more carbon dioxide and growing increasingly acidic. But it's in the Arctic that the effects of global warming are most evident. This is the Northwest Passage, a frozen expanse of sea ice off the coast of northern Alaska. During the Age of Discovery, countless explorers tried to use this passage as a shortcut between Europe and Asia. They failed. The ice was too solid. But in 2007, something extraordinary happened. The Arctic sea ice broke up and melted at an unprecedented rate. There was 23% less than in any previous year recorded. The sea ice retreats every summer, but in 2007, so much disappeared that for the first time ever, large vessels could navigate through the Northwest Passage. If this rate of contraction were to continue, there would be no summer sea ice in the Arctic by 2020.
If we lose all of the sea ice and it doesn't reform, which is a possibility, you lose it at the end of the summer, and maybe so much solar energy has been absorbed by that water that the sea ice never reforms, then you're going to have major and essentially permanent changes in the climate in the Northern Hemisphere.
For 28 years, US Geological Survey biologist Steve Armstrong has been spending his winters in the Alaskan Arctic collecting extensive data. He is studying one of the most magnificent animals on the planet. The polar bear is the largest carnivore on land. Superbly adapted to living in this unforgiving wilderness for the last 300,000 years, it cannot adapt to climate change.